is Davinia Hernández-Leo, and full professor at the Universitat Pompeu Fabra in Barcelona, vice president of the European Association of Technology-Enhanced Learning, and with me, this is Christian Glahn. Do you want to say hello, Christian, before I actually do the formal presentation of the webinar?
Of course. Thank you, Davinia. My name is Christian Glahn. I'm a senior lecturer at the Zurich University of Applied Sciences in Switzerland. And my main focus is their digitization and data sciences, and at the same time, education chair at the EATEL. Thank you, Davinia.
Thank you, Christian, for joining the webinar, joining me as moderator. So in EATEL, in the European Association of Technology-Enhanced Learning, one of our activities is organizing webinars. And we say that they are part of a webinar series on transversal topics in learning technologies. So we try to cover aspects that have to do with doing quality work and quality research in the field, aspect that had to do with responsible research and innovation, and aspect that had to do with the interdisciplinary characteristic of our field. This is the 4th edition of our seminars, and this seminar is has the title of "What do we mean with learning engineering and technology-enhanced learning?" As said, the learning technologies domain is intrinsically interdisciplinary. And there are professionals, or there are an intersection of disciplines from the educational and social sciences perspective, as well as from the perspective of technology and engineering domains. So this is really an interdisciplinary field of research and professional practice. In the domain, we are using different names, different terminologies that refer to this field. From educational or learning technologies to technology-enhanced learning, and more recently, learning engineering. So in the case of technology-enhanced learning, and this term was coined in the context of working groups of the European Commission some years ago, and the term was then broadly used to designate a field of research aiming at improving learning by integrating current technologies and designing innovative ones. Now the term has been established, has been adopted by our European Association, by a conference, in a European conference, and by a summer school. Then the term learning engineering, even it has been used more recently, it's first use dates back to the 60s when it was used by Herbert Simon, professor of computer science and psychology at the Carnegie Institute of Technology, to describe a class of professionals who could be experts in designing learning experiences. So this term has been gaining more attention given the initiative that started recently by the IEEE Industry Consortium on Learning Engineering, aiming to develop a profession within the field of engineering. So in this webinar, we are pleased to have with us Goodell, representing ICICLE. He will elaborate on the term learning engineering and the current efforts by ICICLE towards the definition of the profession. So Jing is a member of the ICICLE steering committee. And we are also pleased to have with us Mikhail Fominykh, from EATEL, representing EATEL. He will explain what we mean by TEL, by technology-enhanced learning, and the current efforts in Europe towards the training of future TEL researchers and practitioners. So the format of the webinar will be a dialogue with introductions by Jean and by Mikhail about learning engineering and technology-enhanced learning. And then they will be discussing around questions that will be proposed by Christian and myself and by all of you attending the webinar. Okay, so now we can start with Jean, please. Thank you. And now the floor is yours.
Thank you, Davinia. I will share my screen with a few slides momentarily. So what is learning engineering? This is the current definition on the IEEE ICICLE website. Learning engineering is a process and a practice that applies to learning sciences using human-centered engineering design methodologies and data-informed decision-making to support learners in their development. You can find a lot more at IEEEICICLE.org. Yeah, and I won't read the description of ICICLE, but please visit ICICLE.org and you can find more. So here's that definition, and I just wanted to highlight three main parts of the definition. Is that it involves learning sciences, it involves human-centered engineering design methodologies, and involves data-informed decision-making. And probably one of the most important things is that in the first line, it's a process and a practice. When ICICLE started meeting about 3 years ago, the direction was, okay, how do we define a learning engineer, the person that does learning engineering? And we found through lots of work and discussions that we were using the wrong approach, because it's not about a person, it's about the process. And the process must involve these three things: learning sciences, engineering design, and data-informed decision-making. As Davinia pointed out, it's not a brand new field. More than 50 years ago, Herbert Simon coined the term, and his vision for learning engineering involved multidisciplinary teams, and he recognized that there was a lot of potential in moving away from an individual professor trying to figure out the best way to teach a group of students, that when people work together, they bring different knowledge sets and different capabilities and an ability to create a better teaching and learning experience, or solve learning problems with a breadth of knowledge that goes beyond what any one person can have. So learning engineering is a team sport, and we, at our conference in 2019, the IEEE ICICLE Learning Engineering Conference, and I think it was the first of its kind, we had a session. This is a slide from that session, and we talked about some research that we had done, kind of a survey of the field of those that are doing learning engineering and what the different models look like. And we saw some cases where learning engineering was someone with a background in learning sciences and data science, working with a professor or an instructor or a lecturer to design better learning experiences for students. And that was just one model. There's also a model where an expert in one of the important fields joins an existing team and acts as a consultant. And the third model was that a team was formed to solve a specific problem. And as you'll see in the next few slides, that's really the direction that learning engineering is going, is dynamic teams that are brought together to solve specific learning problems. So this flower diagram is a representation of the kinds of knowledge domains or expertise that might be applied to a learning problem. and solved through a learning engineering process. Learning science, data science, software engineering, instructional design, learning environment engineering, if it's a physical space problem, education expertise, assessment, measurement, evaluation. This is an important part because part of the learning engineering process involves measurement and instrumentation and subject matter expertise, of course. For this to work optimally, each of the people that bring different domain knowledge to the problem to be solved have some shared understanding so that they can be speaking the same language and understand each other as they go about solving the problem. So learning sciences includes a lot of different areas of science, cognitive psychology, development psychology, social psychology, etc. I will not read the slide to you, but let you read yourselves. And data science is the last one listed there. That's very important for what ICICLE considers the learning engineering process. And so it must be data driven. And it's a creative problem solving process. So we look to the recent developments in methodologies for human-centered design and involving the person or people that are going to be the recipients of the solution in the design process. Here is a working model, and I'm going to end with this. There's currently a special interest group within ICICLE that is working on developing this model and ensuring that it can be generically applied to all kinds of learning engineering uses and cases. So on the left, it starts with a problem. And then understanding that problem and understanding the context around that problem. That context could be things like a physical environment or an online environment that say a learning experience will be delivered within. It could be, the context could include the set of learners that are going to be involved in a learning experience. The problem could be about a specific kind of learning experience for a specific topic, or it could be something that's more general that impacts learning, like students being able to get to school, or engagement of students in a variety of learning experiences. But whatever that problem is, it needs to be understood at a deep level. And then, okay, this isn't the latest version of the model. The latest version has, in that first arrow that goes from context and problem to design, is team selection. So the idea there is that the composition of the team would be selected based on the problem to be solved. So in some problems, you may need someone with expertise in software design because the solution involves creating a piece of software or software engineering. Other problems don't involve software, so you don't need a software engineer. The same thing with other areas, and certainly in most cases, it would the problem would define what domain expertise or content knowledge needs to be represented on the team. So the design and instrumentation is an iterative process that involves designing the possible solutions to the problem. That could be, the solution could be a course, or it could be a unit within a course, or it could be, if the problem has to do with environmental factors like distractions, solving the problem so that students can be more engaged. The instrumentation is an important part of the design cycle, is defining how the team will collect data and what data are collected when the solution is implemented. Implementation is using the solution with real people. And that could be done in a evaluation kind of way, or it could be done in a real world situation at a larger scale. But however that's done, the students or learners are experiencing the solution, this first iteration of the solution, and they are, and there is data collection going on. So as we come out of the implementation, this first iteration of implementation, there's data analysis, and based on the results of that data analysis, it informs the next iteration of the entire process. There's an assumption that something that is going to be designed through learning engineering won't be designed once and then the team walks away, but that there'll be at least a second cycle because nothing is perfect the first time. The analysis of the data from the first implementation tells us what problems might still exist or imperfections in the initial solution, and that gives an opportunity to give another iteration of the problem, of solving the problem. I'm going to stop there.
So now before the questions and discussion, I will ask Mikhail to present. So Mikhail is also a member of the EATEL board, and he's the general chair of the summer school of the EATEL Summer School on TechnologyEnhanced Learning. Since recently, he's also the coordinator of the Doctoral Education for TechnologyEnhanced Learning project, the EATEL project funded by the Erasmus Plus program in Europe. So now the floor is yours.
Thank you. Thank you. I would like to share my screen now. All right. So I would like to start with the term technology-enhanced learning and say a few words about it, and then introduce the European Association of Technology-Enhanced Learning as the main community and the main vehicle for the development of the term and also our main activities. So technology-enhanced learning, or TEL, is a term that, as Davinia said, that was coined by the European Commission in the year 2000. And at that time, there was a dominant term, e-learning, that was slowly becoming associated very much with learning management systems. And a new term was needed. And then the term was also supported by the early networks of excellence in Europe that in their turn were also supported by the European Commission. And later on, the European Association of Technology-Enhanced Learning was carrying the term, and also the community of researchers and practitioners in Europe started to form and also used that term. So as a possible definition, I found two quotes, and I think they're both right, and they both highlight slightly different aspects of the field. But the first point in the first definition here that you can see on the slide is that the TEL is a field of research, and I think this is an important point, and somewhat a distinction of the term from several other terms that are being used. That it was started as a research field, as a multidisciplinary research field that includes education or learning. It includes technologies and other related fields such as psychology, many other humanities and engineering fields. And it has two major components, learning and technologies. And also it has a somewhat hidden component of enhancing, so that it's not only learning and technologies that happen by themselves, but enhancement is an important part. So some of the research and some of the practice that the field is looking at is applying technologies for learning or enhancing learning using existing technologies, but also, and very importantly, designing new technologies for better enhancement or more positive effects on learning. There is another definition here you see on the slide as a direction towards human development or development of competence using different tools in isolated or collaborative settings, or formal and informal. So very broadly developing competence and also skills using digital tools. Very recently, we looked at the trends in different countries that are used to describe similar phenomena in different countries. So the term technology-enhanced learning is mostly used in Europe, but also if you look country by country, you'll see that North America, China, and a few other countries also in the world use the term educational technology. Some other countries prefer learning technologies or digital education, and then also a few countries use the term learning engineering that's been just introduced by Jim. The terms digital education and learning engineering, I think, appeared relatively recently in common use, even though they're not very new, but I think digital education has not been used in the as early as learning engineering. So there are many other terms that are used to describe similar phenomena in addition to TEL and learning engineering. Now I would like to introduce the European Association on Technology-Enhanced Learning, which has been supporting the community in Europe, mostly researchers, but also practitioners and professionals in the field. The association seeks to drive the community and the community discussion and help maintain standards and research quality and professionalism in the domain. The association has three I would say two main flagship events: the European Conference on Technology-Enhanced Learning, EATEL, the joint Technology-Enhanced Learning Summer School, or it's also called EATEL Summer School, and also DTEL, the Doctoral Education in Technology-Enhanced Learning project. I'm not sure if this slide is visible. I'll try to hide this. I would like to say a few words about each of them. The European Conference is also, both the conference and the summer school started roughly 15 years ago. And this year, both events went online. The European Conference, again, on technology-enhanced learning, engages mostly researchers with in the field of technology-enhanced learning, and has a very steep acceptance rate. So the conference prefers high-quality articles in a lower number of them, but also in the recent years made some attempts or in some enhancement of the activities to include practitioners, developers, entrepreneurs, industry representatives, and last but not least, policymakers. Now the conference has a very broad spectrum, many target groups, and supports the discussion involving all of those. The summer school is an event primarily for doctoral candidates in technology-enhanced learning. So the association and the summer school realize the importance of doctoral education in the field of technology-enhanced learning as a starting point in research, in training new researchers, and ensuring the high standard of research in the field. It is called the European Summer School, but it is called European because it happens in Europe. We always have participants from all over the world, from North America, Asia, Africa, and so on. I can say a few more words about the summer school. It has just celebrated 15 years. It's been in many European countries throughout the years, as you can see here. This is a photograph from last year in Italy. We had about 90 participants. 2/3 of them are PhD candidates. We have usually a couple of master students as well, and many researchers organizing sessions. And I can also present the venue for the next summer school that we're planning in 2021. It's going to happen in Greece in May. Unfortunately, this year we couldn't organize it in a face-to-face format. I can also say a few words about the event, as we took the opportunity this year, since we couldn't organize the event face-to-face, and we looked at defining an activity framework for doctoral training. And we analyzed the programs of all the summer schools from 2005 until 2020. And we came up with a framework to include thematic workshops where a specific topic is being presented and some activities organized around it. Workshops about soft skills, such as presentation of research, academic writing, and so on. Sessions about the research methods and research methodologies that are used in the field. Keynotes by the well-known researchers. Informal learning sessions, various discussions, games, and very interactive and very informal sessions that don't require much preparation, and also career workshops. We also looked at how our doctoral education activities reflect the development of the field throughout the years. We also analyzed the program, and just to remind that every year the summer school announces a call for presenters, for workshop organizers, and any researcher is free to submit a session on any relevant or related topic. So we every year have maybe between 25 and 50 submissions, And we looked at them in retrospective and analyzed and tried to cluster them. The clustering algorithm came up with this, well, many options, but we thought this one makes particular sense. And it also shows the development of the field throughout the years. And this, for example, you can see cluster number 1 on the bottom, personalized, contextualized, and adaptive learning. That has been very popular from 2006 to 2009 and started to slowly decline. Or you can look at also cluster number 4, learning environments. That was very popular up until 2010, but then almost disappeared. And yeah, open education has always been around, but in a recent couple of years started to explode a little bit. And I would like to conclude with a new initiative, DEATEL, Doctoral Education for Technology-Enhanced Learning. This is a new project where a consortium of 9 universities together with EATEL looks at and aims to improve the doctoral training in the field. And we have 4 major objectives. We are in a few days starting a survey to identify the good practices in the doctoral education field. We are looking at then, based on the results of the survey, create a program or curriculum for doctoral education in TEL and design a few high quality open educational resources for the most useful and least available topics in the field. We will also, we plan to organize 2 winter schools to evaluate the new program. And also we will do as much as we can to exchange and spread the good practices in the field. So I would like to stop here and then proceed with the program. Thank you.
Thank you very much for your presentation as well, Mikhail. I think very clear. So now we start with a dialogue. I will start proposing a question for the 2 of you, and then you can freely answer and discuss between the 2 of you. So my first question would be, how do you compare then, in view of the 2 presentations, how do you compare the terms being used on learning engineering and technology-enhanced learning? Do we mean the same with the 2 terms, or they're really different perspective in each of them? In addition to that, I would also like to know your views regarding the missions. How do you compare the missions of EATEL and ICICLE? I think that Mikhail explained the mission of EATEL, the European Association, but maybe Jin can elaborate further on what is ICICLE and the mission of ICICLE and the efforts of ICICLE, including the conference that they organized last year. And probably they will keep organizing in the future. So that would be my first double question, if you want. Okay, so feel free. And if you maybe, Christian, you want to elaborate on that before they go?
Yeah, I want to invite also the other participants to post their questions in chat or raise their hands to ask their questions too. So this is not a question among the few of us, but among everybody here.
Good point, Christian. Thank you very much. So now, Jing or Mikhail.
Okay, I see a lot of overlap between the terms, and but they're not exactly the same. Where technology-enhanced learning starts with the word technology, so it's focused on the use of technology. Learning engineering can involve solving problems that don't use technology or don't use what we typically think of as technology. So at the 2019 ICICLE conference, Shelley Blake-Plock, who was the chair of ICICLE at the time, did a presentation on a learning engineering problem in sub-Saharan African country, where the problem was that students weren't getting to school. And because the school was so far and it was a long way to walk and they didn't have transportation. And so the solution to that problem was to provide donkey carts to the villages, and then the older students would drive the donkey carts and pick up the younger students and get them to school. Yes, it is a donkey cart is in a sense a technology, but it's not what we typically think of as technology. But I do like the overlap in that both TEL and ICICLE are focused on the concept of competence and competencies. It's no longer about getting students into a classroom and having them spend a certain amount of time in a seat. It's understanding that the real goal is that the students learn something. And this focus on human development of competence, whether inside a classroom or elsewhere, is where I think there's a lot of synergy between the missions of the two organizations.
Thank you, Jim.
Thank you. I think I can add also that what I see in ICICLE is that it's very practice oriented and also has a defined process, which is I think it makes it more focused and it's more clearly defined. And I think in TEL, this is one of the biggest challenges, that we don't have a defined process or defined process or methods. And the field is very multidisciplinary, and it comes with a lot of challenges associated with that. And very often we see researchers trained in one field attempting to do research in the multidisciplinary field or development or practice. So those who come with training in educational methods, they are coming from their perspective, and then others come with technology background, engineering or software engineering background, and with the skills and knowledge in methodology in that field. It leads to great results when these people work together and develop new and creative solutions, but also very often it leads to misunderstandings and also some discussions on what is TEL, what to include and what not to include. And I see that also in reading reviews of the works, that some people make or give a lower results, saying that this is on the border or not relevant to TEL simply because it provides a different perspective, either learning or too much of a learning there or too much of the technology there. Yeah, but the overlap is very clear, that we both terms are very often used to describe the use of technologies to improve learning.
So I'll put on one of my other hats. I'm also the vice chair of the IEEE Learning Technology Standards Committee. And it seems like there's also a lot of overlap between the work of that standards body in terms of the different kinds of technologies that, like the slide you showed, that showed the trends of over time of the different kinds of technologies. And I can see in some of the IEEE standards work within the Learning Technology Standards Committee that the the newer kinds of standards that work groups are developing get into some of the emerging areas that you're seeing, kind of the shifts to things like wearable and social learning and things like that. The other one big trend that we're seeing is the need for standards that have to do with student privacy as well.
Yeah, that's an interesting perspective because it connects with the technology orientation that is maybe more stressed in the technology-enhanced learning term that you mentioned. Another question that I think is interesting for discussion, or I would like you to further elaborate on that, especially Jim, because Mikhail explained how in Europe the training of people involved in working with learning and technology, or combining all these the different disciplines, the training is quite varied. So in Europe, there are a number of master programs around learning and learning technologies, so to say, and there are also, and people also develop research or train themselves as researchers in the field in the frame of different PhD programs. So this is why there is this effort in the EATEL project that tries to put together like a standard umbrella about what is understood by the community that could be the competence that would need to be developed by TEL researchers, so to say. So I think it would be interesting to see what is the perspective of ICICLE into that. So there is nice definition of what is a learning engineer as a profession, as an intersection of different disciplines. But then how is the training of these professionals and envisioned?
Yeah, so we spent a lot of time in several special interest groups looking. We thought that was our first mission, was to define the training for a learning engineer. And we realized after a lot of work that that was not the starting place, that we first needed to define the process. Without a process, there are so many different kinds of learning, so many different kinds of problems that need to be solved, that need learning engineering solutions. And we can't anticipate the kinds of problems that might come up in the future, especially as we get into new kinds of technologies like AR and VR technologies and new kinds of instrumentation of learning. So right now we're focused on defining that process that is universal for all learning engineering. But the next step is, once we have that process, to define what are the competencies that are needed within different steps of the process, and then within different problem spaces. And we will eventually get to that place where, but instead of defining a one-size-fits-all competency framework for learning engineers, we'll be defining a competency framework for learning engineering that has all of the competencies defined that may apply to different kinds of learning engineering problems. And then when teams are selected to solve problems, they know that they need to have people on those teams that have the right set of competencies to solve the specific problem within the specific context that is being solved.
I think it is an interesting approach that you attach the competencies to specific parts of the process, steps of the process, and not necessarily to a single person who is a learning engineer? Or is it the same? Should it be a very T-shaped person with a lot of, with a wide variety of skills and all in a single individual, or you don't think that is a possibility?
So I think what we found is that in order to scale the field, we need to not assume that everyone can know everything. So there is the T, but how much the person knows in terms of the breadth at the top of the T versus the depth may vary based on organization. So I think what we're trying to define right now is what is the minimum top of the T, the breadth that everyone needs to know so that they can talk to each other on the team. And we're going to know that there are certain parts of the process where we need at least someone on the team that can bring expertise. So instrumentation is a good example. If the problem is we're creating an online learning experience, then, and we already have a platform that does the instrumentation for us. Let's say it's a platform that uses a standard like XAPI, Experience API, to collect clickstream log data. Then we don't necessarily need someone on the team that will build that infrastructure because we already have it. But we definitely need someone who can interpret the data. We also need someone that can, one or more people on the team who can understand what data needs to be collected and how it needs to be collected using the current infrastructure. In other cases, we may need someone to build the infrastructure. In other cases, it might not be an online learning experience that we're creating. We're creating an experience in a physical space, and there's different kinds of instrumentation that we may want to consider. At Carnegie Mellon University, they have teams that are of researchers that are experimenting with instrumented classrooms, for example, using cameras and microphones placed in different places, and artificial intelligence watching the room to do things like face tracking and alert the instructor that that a student maybe in the back row may be frustrated or confused, and that gives real-time feedback to the instructor that they can maybe need to explain something in a different way. There may be different kinds of instrumentation used in project-based learning, for example, and maybe instead of trying to observe everything that's going on, there's some kind of interface where someone on the team working on the project is using that interface to track what the team's doing. I guess what it comes down to is there are certain roles and competencies that will be needed for the generic process, but in a lot of cases, the specific competency set that will be needed will be based on the problem and the context as well.
All right, I think this is an interesting perspective with the roles and with defining the T shape, or the breadth of the T. And I think what EATEL is focusing is on defining the field, probably together with what is the minimum training that is needed in the multidisciplinary field versus training of researchers or researchers in the field that is currently being done within monodisciplinary fields such as education or computer science. I think maybe Christian also can add here in the perspective of EATEL on the practitioners, because my perspective is mostly in TEL being a research field.
Well, I phrased that then into a question to the both of you, because for practitioners, it's very, very complicated because we have all kinds of technologies, all kinds of perspectives. And if you're a young person coming out of school and looking at all the different perspectives, probably starting to specialize after your bachelor's degree or so, I'm wondering, because learning engineering or TEL are so rapidly moving, as Mikhail showed earlier in his diagram, in his graph of topics, and the great variety and standards that coming out of IMS, out of the IEEE and so on. What does that mean to people who are starting to build a career around learning engineering or TEL from your perspective? What are the key points that young professionals who are interested in the field, what should they look first at from your point of view?
So I think it depends on what they're starting with. So if they have their initial education in, say, software engineering, and they want to go into software engineering to solve learning problems, then they probably need to learn something about the learning sciences, and they need to learn something about data science, and about the process of human-centered design, and that combined with their software engineering background is probably the basis for them to start contributing to the field. If they're coming from a different background, let's say they're a subject matter expert in a content area, and they're trained to be a teacher in, let's say, language or science, then they need to understand learning sciences, how people learn, and they at least need to understand what technology is capable of. They might not need to write code, but they need to understand what's available in the toolkit to solve the learning problem.
Thank you. I think also I can add here that the question from Christian is a little provocative, because what they need to look, it doesn't not really exist, because what I think ideally they should look at is a clear definition of the field, saying that would say that a technology-enhanced learning or learning engineering expert is a person who knows A, B, C, D, and who can do X, Y, Z, and who works on problems like this and that and looks for solutions here and there. And all of those, A, B, C, D, and so on, need to be general enough to last for at least a few years, and include naturally all the new fields and developments that we are experiencing in a fast developing field. And I think this is also partly your effort in learning engineering, defining the process and the roles and the profession, and also in our field defining what is a minimum training, so that the fresh master degree holders can choose a path to go either to practice or to research in the field, so that they would know what they have. They can compare it to what they would have in 3 years of doctoral training, for example. And there is no common ground, and that's very varied in both training, research, and practice, I think.
And I think we could learn from you how you're defining that, and it could inform kind of the next step that ICICLE will take once we've settled on the process. That's what we're going to be trying to build out, is that competency framework, and flagging which of the competency definitions have to do with the minimum set that everyone working in learning engineering should know, versus the depth that might be applied to a specific problem.
That brings me to another question. Thank you, Jim. When I'm thinking about this common set, and I'm looking at your learning engineering model, that reminds me a lot about Garnier's ADDIE model. I'm thinking from this rather stringent model perspective, how, if you think a learning engineer who has this common set of competences is a person who primarily reflects the customer's perspective on learning, like school employees and learning engineers, be it as consultants or be it as teams, that these people need to reflect their understanding on how technology and how certain kinds of educational problems should be solved in that organization? Or do you think that such engineers also need an innovative momentum as a disruptor, maybe, in an organization? What is your take?
Well, I guess my take is, I heard two questions there. One was about the ADDIE model, and I'd like to talk about the comparison, and then and focus on what the customer thinks they want, or focus on innovative ways to solve the customer's problem. And I think it's probably more to the latter, focusing on solving the learner problem. But I understand that there's a dynamic there that unless the right process is used, it's hard to get to solving what the real problem is, and unless the customer is part of the process, and it's kind of a shared new understanding of what the real problem is. And the human-centered design methodology, like that's available through Open IDEO, is a good example of how those that are trying to create solutions and the people that they're creating the solutions for work together to come to a better understanding of what the problem is and what the best possible solution is. So the other question was the ADDIE model. So a lot of discussion has gone on with people from the instructional design field within ICICLE. And we recognize that in a perfect world, the instructional design is the same as learning engineering. It's iterative and it uses data to inform those iterations. But in practice, we're not seeing that really happens. And even though the ADDIE model in an ideal world is used in an iterative way and informed by data, in practice, it tends to be a waterfall kind of process that just creates one instance of a product, and then the team or person moves on to the next project. And that's probably a big part of the difference is whether instructional design could also be considered learning engineering is the level of data science that's involved and the level of iterative human-centered design is involved.
I think I can add a small point here. The question, I think, was both of them were related to the degree of freedom and innovativeness that you can incorporate as a researcher or as a practitioner. I think the reason why the practice in instructional design follows very often a waterfall approach is that they have other limiting factors such as time, and there is not enough time to engage the users and better understand the problem and so on. So the practice, like with the recent pandemic, there was no time to develop solutions using the learning engineering process because the solutions was needed today, this afternoon or tomorrow. There is an activity and we need a solution. And I think this is also related to the interaction between research and practice. As we see that research projects take longer, they have the possibility to try different solutions, the trial and error process, and then develop further what is more what has better results. It's more data informed or research informed approaches. So they could also influence the practice process wise.
And I think that's really a challenge to us as a community to help to try to figure out ways of shortening iterative cycles and maybe learning from the field of agile software development and finding ways of doing design for learning that are done in sprints, finding ways of engaging the customer or the end users that don't involve, let's say, formal kind of the formal process of a focus group or something like that. Maybe it's just a Zoom meeting that shows some wireframes of a user interface or something like that, and gets a quick reaction from some users, or brings the design team in contact with some end users, just to ask some questions to check their assumptions. I'm just thinking out loud, but there are probably ways that are not being employed, that could be employed, that would not be a significant amount of time.
It is indeed a very interesting discussion now, where there is this converging movement on how to move design-based processes, not only to research, but also to practice from a human-centered and data science approach. So yeah, it's a quite timely and relevant discussion in our field. Let me now ask you if you would like to propose a question to the other. I don't know if Jim would like to propose a question to Mikhail and the other way around regarding the different perspectives.
Sure. Mikhail, as you're developing your competency framework for training in learning or in I guess technology enhanced learning, are you developing that in a way that it's going to be available in a machine readable form where the definitions are can be accessed individually, or are you planning to publish it in more of a human readable form like a PDF document, or both?
Okay, thank you for the question. I see where it comes from. Well, the current plan, or the original plan, was to simply gather the good or best practices in doctoral training, look at all different perspectives, see the overlaps, analyze them, and create a program or a curriculum that would define the core of the field, of the competencies in the field that are needed for doctoral candidates or for researchers in the field, and look at all the directions or peripheral fields also, and define them. That was planned to do in the human readable format. But yeah, since you mentioned it, probably this could also take another round and yeah, put it into standard and make it machine readable somehow. Don't know if you can. I really answered the question. I have another one for you, but
yes, and there are some existing standards and open source tools as well. For there's IMS Global has the case standard, and there's a tool that an open source tool called Open Salt that lets you input the competency definitions in a framework and also link to things like rubrics. That was developed based on the definitions for rubrics and competency frameworks that came from the Common Education Data Standards, ceds.ed.gov, that I've worked on. There's also an open source project called CASS, C-A-S-S, that it has a similar tool that was developed under the U.S. military for their training. And they're both, and CASS can also do some translation between the IMS standard and some other standards that exist for competency framework data. I'm ready for the question.
Yeah, we will definitely look at tools for designing competency frameworks. Let me collect my mind about the question for learning engineering. So what I see in learning engineering is it's very problem oriented and very practice oriented, and I was thinking, how does it incorporate the research and innovation into either the process or in the competency or the definition of the learning engineer?
That's a great question, and in fact, there are two groups that are active that with some overlaps with people are involved in both. There's a learning engineering Google group in the U.S. that is mostly from the research side. It's mostly learning sciences researchers. It involves people that like the people at Carnegie Mellon University and Stanford that develop intelligent tutoring systems, and so they're really focused on the research side, and then there are people that are in both groups and bringing the latest research knowledge from the research-oriented group to the ICICLE group, and that's focused more on the process and practical side of it. So, there's been some overlap in both with researchers involved in ICICLE as well. So the special interest group that I currently lead was originally led by Ken Kadinger at Carnegie Mellon, and others like Aaron Kessler at MIT are now leading the design SIG within ICICLE.
Thank you.
Thank you both. We're coming quickly to an end, so please let me wrap up. I think we had a wonderful discussion going on, having the two different perspectives on TEL as well on learning engineering. And what I really like is the common ground on developing competences and also building these kind of competences around a framework. Mikhail demonstrated a little bit his the ideas from the DTAP project with respect of the process of becoming an educational technologist or technology-enhanced learning specialist or researcher. And Jim, you really elaborated on what does it actually take to understand the competences that we need to build. I really like the two perspectives and the discussions that are going spinning off from it. And when I listening to you, I'm thinking all the time, yeah, we need to become more agile and we need to become innovative and so on and so forth. And at the same time, we're sitting in educational institutions at the end of the day and educational organizations. And as we know, they are not extremely agile and high speed when it comes for transformation and innovation. I think that is a good wrap up and opens up the question for another session to come together and maybe have another ICICLE EATEL session together to focus on what are probably the organizational elements of people who of innovating education on the impact of technology and engineering processes in education, and also what you both already tackled. What is the role of data? Yeah, what are data science skills that we need to tackle these days? I thank you very much for your wonderful inputs. And I go away with a lot of questions and a lot of inspirations from your inputs. Thank you very much.
Thank you very much also from my side. I think this dialogue really provided light into our understanding of what we mean with learning engineering and technology-enhanced learning.
Thank you very much. Thank you, Christian, Davinia, for organizing the webinar, and Jim for a great discussion. And I think my understanding of learning engineering is much better at the moment, even though I've been involved in one of the 6.
Thank you. And I definitely want to have some more conversations because I also have questions, and I'm looking forward to that.
Okay.
All right.
Thank you all. I will start the recording.